Okay, man, I see this concept get overcomplicated all the time. If you ask 3 engineers, what is the people load, you'll get 3 identical answers. But if you ask them, what is the ventilation load, you start to get all sorts of different answers. And I think the dissonance here comes down to definitions and a lack of agreement on what ventilation load means. I'd like to get a consensus, and I'm going to start simple, logically break down what ventilation load is, explain how to calculate it, and then go over why there's confusion. But first, we need to agree on some definitions, so let's take it back to first principles and come to a conclusion on what is ventilation load. Let's deconstruct these terms. So load is the amount of heat a system either needs to add, that's heating load, or remove, cooling load, in order to maintain a desired air condition in a space over time. Load is caused by a variety of factors that either add or remove heat in some way. These factors are also called load components. Now, as engineers, we break out load components because it is important to understand exactly what factors are contributing to the load and how much. Some examples are people, lights, walls, windows, and ventilation. Ventilation is the amount of outdoor air intentionally added to the space. So, when we ask what is X load, we are asking, all things aside, how much heat does the system need to add or remove to counteract the effect of X in the space and thereby maintain the desired space air condition? Now replace X with ventilation. We are asking, all things aside, how much heat does the system need to add or remove to counteract the effect of bringing in a certain amount of outdoor air to the space? Okay, in agreement so far? The reason this gets overcomplicated is because rather than answering the question literally, engineers hear this and they start to answer different questions. They answer how the ventilation load is handled or where it's handled. And in doing so, they start to conflate ventilation load with other load components. They start to conflate it with coil load, which is a different thing. And I'll explain this further, but first let's calculate what is ventilation load. Let's use this example. In our space, we have a desired indoor air condition of 72 degrees dry bulb and 50% relative humidity. Now, per requirement, let's say we need to bring in 1,000 CFM of outdoor air, and that outdoor air is 100 degrees dry bulb, 80 degrees wet bulb. What is the ventilation load? Another way to ask this is, what condition do we need to get this 1,000 CFM of outdoor air to such that its effect on the condition inside the space is 0? That should be easy to answer. It needs to be equal to the indoor set point. If this outdoor air is 72 degrees dry bulb and 50% relative humidity, then there is 0 load. So to calculate ventilation load, we need to calculate how much heat we need to remove from this air in order to get it to 72 dry bulb, 50% relative humidity. Let's do that real quick. The simplified formula for total load is 4.5 times CFM times delta H. We know CFM, so let's plot these air states on the psych chart to find our enthalpy. I'll use HVACR's interactive psych chart to do this pretty easily. These are the states that I referred to. State 1, 180, enthalpy is 43.36. And then indoor state, 72 with 50% relative humidity gets 26.39. So let's get that down. Solving for this, we get about 76,000 BTUs of load. That is our ventilation load. That is what we have to do to this air such that the effect on the space is 0. Pretty straightforward, right? So why do engineers have different answers to this question? I think it has to do with how ventilation load is handled. It's a unique load component because it doesn't come from the space directly. Oftentimes it's brought in at the central air handler and is fully conditioned before it ever gets to the space. Sometimes the load is even split up. The outdoor air might be tempered at one unit, then fully conditioned at another unit, like an ERV serving 4-pipe fan coils. So engineers tend to jump ahead and start addressing how the ventilation load is handled. And when you do that, it's easy to conflate ventilation load with coil load. And those are two separate things. So let me demonstrate what I mean with an example of this. You may be bringing that outdoor air in and handling your ventilation load at a central unit. And you may even be conditioning that air down to 55 degrees below the indoor set point. And the temptation with this setup is to say, well, to calculate my ventilation load, I need to calculate the difference between 100 degrees and 55 degrees, because that's what I'm doing. But that's not ventilation load. That's actually coil load. And that conflates your ventilation load with the other loads in your space. I'll explain. Why do you condition it down to 55 degrees? The reason you bring in 55 degree air to a space is because you need that temperature difference to handle your space sensible loads. And so when you bring ventilation air down to 55, you're already contributing to the people load, lighting load, exterior wall load by subcooling it, and now that temperature difference can address the other loads in the space. So that's what I mean when I say ventilation load can get conflated with other loads, with coil load. And I think to eliminate confusion, the solution is to use the terms correctly. So if you want to know the ventilation load, ask what is the ventilation load. But if you really want to know what the coil load is at a specific unit, then ask what is the coil load. And for that, you've got all the psychrometric characteristics that go into it. And yes, that coil load might be handling your ventilation, but it's likely handling other load components as well.